like is an analytical device which incorporates a biological active element with the appropriate physical transducer to generate a measurable or detectable signal, which is always proportional to the concentration of the chemical species of any type of sample. In this biosensor, we are seeing the
Sir, excuse me, sir. Your screen is not visible, sir.
yes, ma'am. Yes, ma'am.
I think there is a network problem.
So, the components of the biosensor are like the biorecognition element, which physically interacts with the analyte or the sample, and it will convert into a suitable form that can be transduced into an electrical signal. And the biorecognition element and the physical transducer are placed together in order to sense the concentration of the analyte. So the sample contains the analyte here, and the biorecognition element is selectively sensitive for the particular analyte, which is a biotarget, which converts in this electrochemical reaction into a detectable form by the function of the transducer. Then the transducer signal can be further amplified and a suitable scaling is applied for the measurement of the concentration of the analyte. So these are the basic principles around the biosensors. So in this biosensor, there are two major components involved. One is the biorecognition element, plays a vital role in converting these biological samples, biological reactions into a suitable detectable form. And the signal transduction element is present that will convert this biorecognition phenomena.
Excuse me, sir. Sir,
yes, sir.
Sir, till now there is no screen is visible.
Screen is not there.
Yes, sir. Now it is visible, sir.
Okay.
Yes. Again, there is no screen, sir. I think there is an
1 minute. Ma'am, give me 1 minute.
Okay, sir. Okay, sir. Sir, otherwise, can you share your screen if you maybe are.
Yeah, I am trying to mail. Yeah. I am trying to mail it.
Okay.
What is, sir? Whether it is going on or not?
Hello. Yeah. Kindly wait. There is an interruption from the PPT side.
Okay,
2
sir.
minutes.
Okay.
Sorry.
Hello, sir.
Yes, ma'am.
Sir, please share the slides, sir. We will share the screen for you, sir.
Yeah. That's what. Ma'am, kindly give your email ID.
Okay, sir. I will send the mail ID in your chat, sir.
1 minute. I'll send it to HOD Bio.
No, sir. No. Wait, sir. I will send you the mail ID. My ID I will be sharing you. So please send for my ID.
Okay.
Sir, did you receive my mail ID, sir?
No.
Sir, in your Samsung Isaac, in that chat I have sent you personally, sir.
Okay. And just log out.
Sir, otherwise I'll spell here, sir. Please note it down, sir.
Yes. Okay.
GS
GS
UD
UD
HA
HA
NT
NT
HI
HI
RA
RA
at the rate of
Gmail.
PSNACET dot edu dot
PSNA
in.
PSNA
PSNACET.
CET College of Engineering Technology.
Yes,
Dot.
sir. Dot edu dot in.
Okay. Thank you.
Dear participants, we are facing an unexpected technical issue. So please wait patiently. We will sort it out within few minutes.
Hello, sir. Yes, yes, visible.
So you can move to the next slide. Next slide. Next slide.
Next slide, Sandra ma'am. Sir, you can proceed now, sir.
Yeah. Please. Thank you. Sorry, dear participants. Okay, so the biorecognition element, the two components of the biosensor are biorecognition element and the signal transduction element. And the function of biorecognition element will convert the biological reaction into a suitable form. Either it is thermal or it can be electro, it can be a potentiometric or amperometric reaction, which can be either transduced by the transducer. The output of the transducer will be in the form of electrical signal that can further be used to find the concentration of the analyte. Next, please. The questions related to the biosensor or the biorecognition element, which in contact with the biological sample, and the transducer that converts the biological reaction into the electrical signal, and the analyte. Analyte is contained in the sample. Sample contains the analyte, which the concentration of the analyte has to be determined. So these are the terms related to the biosensor. Now we will move to the various types of biosensors. Next slide. Next slide. Next slide. The electrochemical biosensor, the biological elements that use the enzymes that is used for detection of through the electrochemical biosensor, which uses redox reaction. And the outcome of the reaction will be a current flow. So in the electrolytic solution. So therefore, we need electrodes to be placed in the electrolytic solution. The current flow can be detected using the electrodes, and the current flow will be proportional to the concentration of the analyte. Then it can be further quantified. Next, please. Next slide. Then the conductometric measurements can be a type of electrochemical method, which the electrical conductivity varies as a result of the electrochemical reaction. So there will be a conductance probe that detects the conductivity of the solution that will be further quantified to find the concentration of the analyte. So there will be an electronic system that is integrated with the probe. So the electronic system will be will show the concentration of the analyte. In the potentiometric measurements, which uses a reference electrode and the measuring electrode. The reference electrode will be having a maintained at the constant potential, and the measuring electrode will have a ion sensitive layer. So that will be attracting only will selectively observe the only particular type of ion, either sodium or potassium, hydrogen, depending upon the type of application. Therefore, the potential difference between a reference electrode and the measuring electrode will be used for the measurement of the concentration of the analyte. In this type of electrochemical reaction, as a recent technology, the electronic sensors like transistors are a sensor center. So the electrical reaction taking on the surface of the drain terminal. Next slide. Next slide. Okay. Okay. Next slide. Okay. And the amperometric is the bias used for the detection of glucose, alcohol, and lactic acid. Bioaffinity sensor, it is mainly used for the estimation of hormones and drugs. Okay. And the electrochemical workstation, which is mainly used for the electrochemical reaction to be measured and transduced into electrical signal. These electrochemical workstations are computer-based equipments which will transduce these electrical signals into a graphical form. And these next slide. Electrochemical workstation are helpful for conducting any research. Helpful for conducting research in which the old and current characteristics are the voltage with respect to the potential and the current with respect to the capacity variations in terms of various types of electrical transducers will be analyzed and shown experimentally and the graphical form. Therefore, electrochemical workstation plays an important role for analyzing the electrochemical biosensors. Next slide. Go to field effect transducer. Next slide. Field effect transducer. Like the introduction of field effect transistors being used as a biosensor as a transducing element in the biosensors. After the induction of this field effect transistor, the measurement system has become very accurate. Like it is the advantages over the conventional type electrode. And the electrodes mainly will face problems due to the concentration of variation of the sample and the environmental parameters, temperature, and the internal reaction takes place. Whereas the introduction of field effect transistors makes this biosensors to be more accurate, where it contains three drain, source, and gate terminal. And the current flow voltage chemical reactions that is taking place in the gate terminal, which will which will generate the electrical potential that will be amplified suitably by using the field effect transistor. Therefore, this has helped the way of implementing the ion selective field effect transistor, which is also known as ISFET, ion sensitive field effect transistor. So, which is an advantage comparing to the conventional type of electrode, which conventional type of electrode has to use two electrodes like reference electrode and the measuring electrode, whereas ion sensitive electrode has a single integrated microelectronic system. Next slide. The ISFET, that is ion sensitive field effect. Next slide. Is a miniaturized, is a form of miniaturized. Next slide. Again, we can move to another slide. It's a miniaturized form of. This one is a miniaturized form of microelectronic biosensor. And this is highly accurate, and due to the sizes being very small, it can be manufactured in bulk quantities, and the cost becomes very, very low. And this can be used for research purposes as well as for the laboratory use, and also for the personal uses. And due to the cost is being low for certain biological sample testing, if it is performed, it can also be disposable type of electrode. And due to the miniaturization and the integration of microelectronics, these electrodes have become very small. This is less than a size of a coin. So these are the advancements of ion selective field effect transistor as a biosensor. Next slide. So these biases have required various types of characteristics, and these characteristics qualify these type of biosensors to be accurately used for applications like biomedical applications, industrial applications, and hazardous applications. The characteristics are sensitivity. Sensitivity plays a very important role. Sensitivity and selectivity are very important. Selectivity is which is selectivity to the particular type of analyte, and sensitivity related to the maximum electrical output it can able to produce due to the electrochemical reaction. So that will help to develop this biosensor into an integrated microelectronic device, which can further be used in the hazardous environment by the integration of wireless technology. Therefore, sensitivity of biosensor is a very important parameter or a characteristic of the biosensor. Then load detection limit. Load detection limit is the minimum amount of electrochemical reaction that is detectable by the biosensor. We call it as the load detection limit. You can also term in electrical measurement like a resolution. Minimum input that can be faithfully reproducible into an electrical output. Then the cost of the biosensor will be low, and due to the integration of microelectronics and bulk production, the cost has become reduced. And it is of biosensors are required to be simple and easy to use. In certain cases, the patient or the attender is subjected to use a particular biosensor for taking the measurements. So it should be of simple and easy to use. The reliability of the data or the reliability of the performance is very important characteristics of the biosensor. Like when it is used for multiple times of the same values, the magnitude of the quantity should not change. That is the repeatability of the biosensor. Then speed is very important. Like when it is used for performing the biosensor experiment, like biological samples, the time of waiting period has to be very, very low. Hence, the speed of the biosensor has to be very good. And the accuracy and precision. Accuracy is very important characteristics of biosensor. How accurate, whether it is, if it is compared with any standard type of standard type of instrument or a electrochemical type method of sensing, it has to provide an accurate result. Then field portability, ruggedness, reproducibility, ease of calibration are very important characteristics of biosensor for designing and development of the biosensors. Next slide. These biosensors produces various advantages, and biosensors now has become has integrated with the microelectronic circuit, which has become very, very small in size.
Compatible with the
microelectronic circuitry, therefore the size has reduced to be very, very small. And since it is manufactured at a large scale manufacturing, the cost has reduced to very minimal, so that it is affordable for patient use and for home monitoring purposes. And it also provides a self-calibration facility, which is also an advantage of a micro biosensor. Next slide. Next slide. So these are various types of electrochemical biosensors, optical biosensors are there, which utilizes the electric and biological reactions to be transduced into either potentiometric method or the conductometric method, or it can be a piezoelectric method. And depending upon the type of reaction that takes place and the output produces, and the transducer component suitably amplify it into a electrical signal that can be again be converted back to the accurate quantifiable engineering units. Then comes the piezoelectric biosensor. This piezoelectric biosensor is mainly used for mass sensitive sensor. That is the outcome of the reaction there will be a change in mass of the analyte or the antigen. Piezoelectric biosensor uses a piezoelectric crystal. Normally, a quartz crystal is very widely used detector for any type of biological sample application, which can able to effectively converted into a piezoelectric biosensor. Next slide. This piezoelectric biosensor having a layer of crystal, which is vibrating at a particular frequency. Next slide. This frequency of vibration is an inherent property of this piezoelectric material when it is subjected to oscillating input signal. And when the antibody is attracted towards the piezoelectric sensor, that deposit that gets attracted by the layer of the piezoelectric crystal. Therefore, the mass of the piezoelectric next slide. Mass of the piezoelectric crystal gets varied. Even it is of micro or nano levels of mass, there will be a change in frequency of the oscillations of the piezoelectric crystal. As we know that if mechanical vibration is given to the piezoelectric sensor, which the sensor can able to convert into an electrical signal, and the frequency variations is used to detect the quality or the concentration of the analyte. Next slide. Quartz crystal microbalance. Quartz crystal microbalance also uses the piezoelectric sensor. It is based on the resonance principle. So a particular dimension of the piezoelectric, next slide, particular dimension of the piezoelectric crystal will be oscillating at a particular frequency. We call it as a natural frequency of oscillation or as a resonant frequency. When there is a change in mass of this layer of the piezoelectric crystal, which can very accurately able to determine the change in mass. If it is a nanogram or microgram, it can able to detect accurately by exhibiting the change in vibration, change in the frequency of output. Therefore, this quartz crystal microbalance is mainly used for detection of mass-based any variation. Therefore, in the biological reaction, the outcome is a change in mass, which can be employed, which this quartz crystal microbalance can be employed effectively to determine the concentration of the sample. Next slide. Colorimetric sensors. Colorimetric sensors involve the measurement of the analyte concentration. Next slide. With respect to the biological reaction that produce, which is an exothermic reaction. These exothermic reactions it will evolve heat. That is a concept of exothermic reaction. This heat will be in the order of very micro millijoule unit, which can be used, which uses a thermal type transducer for sensing its characteristics. The thermal type sensors are usually thermistors are useful for transducing this heat evolved by the exothermic reactions. Therefore, this implies, next slide, this implies a bioreactor which having a, next slide, which having the two thermistors are employed in this bioreactor. One at the reference thermistor, and on the top of the, at the exit of the bioreactor, there is another one more thermistor. So thermistor senses the temperature when the reactants is input to the bioreactor, and one more sensor is placed at the output of the bioreactor. So the reference temperature is maintained, and as a result of the reaction, the heat is evolved, that is the exothermic reaction. Therefore, there will be a minute increase in the temperature. The temperature varies in the range of in the order of Kelvin. So it will be in the 0.001 degree Celsius to 0.1 degree Celsius. Variations only takes place in this biochemical reaction. Whereas the next slide, this thermal, this amount of energy that is evolved, which is also based on the type of biochemical reaction that is taking place. And it is specific to the particular substrate. We want to detect a particular enzyme, and it is specific to the particular substrate. For example, glucose oxidase, a combination of glucose sensitive layer to be present on the substrate. And during the exothermic reaction, 80 kilojoules per molecule of heat energy will be evolved, which is very low, and it is very difficult to observe this heat variation. By employing this high sensitive and high accurate transducer, it can be able to be measured. Therefore, next slide. Therefore, this what are the characteristics that is required for thermistor or the thermally sensitive biotransducer? In the very few important characteristics are highlighted here. The sensitivity of the biosensor is very important in case of thermal sensitive biosensor, because the temperature variation is very low, in the order of low values of Kelvin. Therefore, it is very difficult to observe this temperature in the range of this small order. Therefore, sensitivity has to be very high in terms of this thermistor. Sensitivity in the sense even the smaller change in temperature in terms of change in Kelvin from 10 Kelvin to 20 Kelvin should be able to be detectable. Kelvin ranges are very low, and degree Celsius is very high, and smaller variations of Kelvin temperature can able to be picked up by using the thermistor thermal, and how much is the sensitivity it produces, how much the simplicity of the transducer is also. It should not be complex, and the thermistor circuitry has to be very simple and adaptable to be constructed as a biotransducer. So these are the various characteristics expected from the thermistor. Next slide. So what is thermistor? Thermistor is a temperature sensitive resistor. We know that the characteristic of the thermistor is positive, negative temperature coefficient, and positive temperature coefficient also available. Generally, it is of a negative temperature coefficient. So if it is a temperature sensitive resistor. So as the temperature increases in exactly around -20 Celsius to around 70 degrees Celsius, the y-axis it shows the resistance variation of 100 kilo ohms to the very few ohms. So 0 to 100 kilo ohm variations can be obtainable within the range of -20 degrees Celsius to 70 degrees Celsius, within the range of around 100 degrees Celsius. Actually, the full range of thermistor is around in the order of 1 mega ohm, and which can able to sense the temperature in the range of 1 to 150 degrees Celsius. Therefore, a particular range of this thermistor is employed for biosensing applications, in particular to this particular applications. And these are the next slide. Characteristics that is exhibited by the thermistor. So thermistor being negative temperature coefficient, and the resistance variation is very high compared to the input temperature variations for around the range of 0 to 100 degrees Celsius of temperature variation. The variations in terms of resistance in the order of many kilo ohms. So that makes the thermistor characteristics to be highly sensitive for even a minimal change in temperature. So that is the most important characteristics of the thermistor. And also the thermistors are highly accurate in sensing temperature compared with other thermally sensitive resistors that is employed in industrial applications. And the thermistors is highly rugged, and it is having high mechanical strength. It can have long life. So these are the characteristics of thermistors. Next slide. Other types of biosensors, like next slide. Optical biosensors uses the principles of, next slide. The bioreactions producing the optical variations, like basics of absorption, fluorescence, or light scattering, which uses the optical fiber for detecting the optical characteristics of the biosensor, or it can also use a photodiode for detecting the light characteristics or change in color. Next slide. Next slide. Next summary. Next slide. Next. Next slide. Summary of biosensors. Yeah, coming to the summary of biosensors, we have various types of biosensors based on the type of analyte and the bioreceptor. Some some classification of biosensors are available, and based on the types of transduction that is available, like potentiometric type of type, or amperometric, or thermoelectric, or optical. Based on the type of transduction, various classification of biosensors are available. And based on the transducer, like a piezoelectric transducer, optical transducer, or electronic transducer, these are having its suitable applications. Therefore, biosensor will have an analyte whose concentration of the analyte has to be determined using the biosensor. In addition to that, there will be a transducer that will convert this biorecognition or the biological reaction into a suitable form or electrical signal, which a combination of a bioreceptor and a transducer that forms the biosignals, biosensors, which is very helpful for determining the analyte concentration in the biochemical reactions. Next slide. Next slide. So these are these biosensors are behind various applications. The applications of the biosensors in the field of biomedical diagnosis and various dangers that is coming to the healthcare sector using chemical terrorism and bioterrorism. And these biosensors should be helpful in determining these parameters and health dangers due to infectious diseases. These biosensors are helpful, and it can able to identify or detect the spread of various diseases in air pollution and environmental pollution. These biosensors play a very important role. Coming to applications of biosensors in a broader perspective, it can be employed in four major areas like food quality analysis, agricultural analysis, and environmental quality monitoring, and also from the biomedical diagnostic systems. And in drug development, biosensors are applicable for crime detection and criminology. Biosensors are used for medical diagnosis. Biosensors can be applicable for environmental quality monitoring, pollution in water, pollution in air pollution. These biosensors play a very vital role, and also in industrial process role to produce a quality output products. These biosensors play a very important role, and also for the detection of biological warfare agents. Next slide. So biosensors are inevitable component that plays an important role in environmental monitoring, medical and industrial, as well as for the biomedical sector. Few applications of applications of biosensors are highlighted here. Next slide. Next slide. Applications. Yeah. The commercial applications of biosensors are very popularly used in the biosensors is the glucose biosensor. And this is there is a huge success story behind this glucose biosensor. Since the glucose biosensor being used in the market by many number of, therefore the demand for biosensor development in especially glucose biosensors are growing every year. And these biosensors are highly stable and gives a high sensitive output and reliable output, and also having low interference. And these biosensors employ a thin strip of material, as you know, which has a biological active substance coated on it. And when a blood sample is placed on the electrode, it creates a biochemical reaction and produces the electron flow, which can be measured using the transducer. And that will again be further amplified, and suitable signal processing techniques are applied to convert into the blood glucose units. So this is the working of a glucose sensor. And this bioglucose sensor have become popular after the invention of Clark's microelectrode. Next slide. This Clark microelectrode is invented by the famous scientist called Clark, and he has used an electrode for finding the oxygen concentration in the dissolved liquid. And after this invention, this particular oxygen concentration detection can be used as a parameter in the medical field for the detection of oxygen concentration in the blood. And in addition to that, the glucose biosensors are also becoming popular in the industry after these glucose biosensors are being developed and used. Therefore, you can go next slide. Therefore, glucose biosensors are very highly popular in medical field. The company, next slide. Company Medicines is the company that manufactures this glucose in the early 1990s. Therefore, around the glucose biosensors are dominating in the market of biosensors for more than 30 years. And the reliability of the measurements by glucose biosensors are very much useful and applicable to all the types of diabetic patients in many applications. Like diabetic patient glucose level has to be tested. The physician suggests the glucose biosensor reading to be tested as the initial stage. Therefore, the major number of tests that is performed around the globe is the diabetic test, and the biosensor plays a very vital role in diagnosing the diabetic state of the patient.
Ma'am, share screen, ma'am.
Yeah. Next slide. Next slide. Yeah. Patient diabetic management is a very important application in the field, in the biomedical field. Diabetic management is like patient determining the patient's blood glucose level. As we know that the patient blood glucose level to be monitored every day, day by day, the blood glucose level has to be monitored, and finally it has to be brought to the normal values if a patient is diabetic. If the patient is diabetic, the condition is like the impaired function of the pancreas or the failure of pancreas as a whole. Therefore, in the absence of pancreas, the insulin secretion will be completely stopped and not available. But everyday meal is taken, for a 3 course of meal is taken every day. That increases the blood glucose level of the patient. That needs to be controlled to the normal level. So in the absence of pancreas, insulin is an external insulin, artificial insulin is required for the patient to maintain their blood glucose level. Therefore, if a patient is identified diabetic by the physician, he will has to take continuous medication to bring it to the normal value. Therefore, during this process, a period of say 3 to 4 weeks, the patient has to be monitored his blood glucose level on a periodical manner, in which case the biosensor, glucose biosensor plays a very important role, and it gives a reliable reading, and every day it has to be tested after a meal and during the night time and during the postprandial and during the fasting time. And whether if by continuous medication, if the patient comes to the normal value, then he can go for diet control. So this is what is called patient diabetic management. In this aspect, glucose biosensor plays a very vital role. And the cost of this blood glucose testing is very cheaper, and this makes the diabetic patient to survive, we can say. Like these are various important applications of biosensors. Next slide. Next slide. Okay, research scope. The research scope for blood glucose, the glucose biosensors are, the recent researchers found that various other areas that blood glucose can be determined is from the skin region or from the saliva. And these researchers has to be again converted into a biosensor or a strip form or either a disposable form, which can be further integrated with microelectronic circuitry, has to be converted into an instrument form, which will be useful for the society. Because of the many number of patients they are using, they are under the diabetic problem, which they find a temporary solution by using this glucose biosensors. And in all, it is also in practice like artificial pancreas, and the need for development of artificial pancreas is also been play a vital role in the diabetic management of the patient. As we know that diabetic patient will carry diabetic insulin pen, and during their travel they can take insulin whenever they feel required. And these artificial pancreas are type of devices which has a insulin tank, with an insulin container, which has to be triggered, uh, uh, which has to be delivered to the patient at a appropriate time whenever required from a wireless blood glucose sensor. Therefore, the research is going on in the development of artificial pancreas. Only a few companies are offering this artificial pancreas. Medtronics is one of the company that offers this artificial pancreas. So a new scope of research is available in the blood glucose sensor or glucose biosensor, where a simpler or another conventional or equivalent method can be adopted for the development of biosensor for the diabetic patients. Next slide. And these biosensors are of ease of use, especially in glucose biosensor. The biosensors are used normally by the physician, and
It's been used by the
technician. Technician, and nowadays that's a glucometer is available in old age patients at home. So the patient can also have a ease of use for the biosensor. Therefore, it is user friendly. To make it user friendly, a lot of design aspect has to be considered in designing the biosensor and integrating into electronics. With a single click of a button, the instrument should be able to read the value after placing a drop of blood. So these are very important parameters in designing the glucose biosensor for medical diagnostic. Next slide. Next slide. Other applications, yes. Other application of biosensors like cholesterol detection has been a need of the hour. Biosensors are required to be developed for glucose detection, cholesterol detection, lipid profile, sensing of antibody and toxic substances present in water, toxic substance in the food, and food security. In various applications, biosensors are need to be developed, and which also requires patient centric or the society centric applications to be developed using other applications of biosensors. And next slide. In the thermistor based biosensors are useful for are used in ELISA equipment, which is very widely used in clinical laboratories. And thermistor based biosensors here given can able to sense the very minute amount of exothermic reaction that it can able to detect. So these biosensors are very critically developed and tested, and has been converted into a suitable applications. And further research is required to identify certain exothermic characteristics or the reactions involved to be converted into a biosensor is the future scope of the biosensors. Next slide. There comes the introduction of the cantilever based biosensors. Next slide. Cantilever based biosensors. This cantilever, okay, we can move next slide. Go to the cantilever biosensors. Next slide. Next slide. Next slide. Yeah, cantilever based biosensors employ which is a type of transducer which can able to transduce a biochemical reaction or biological reaction by using a cantilever micro beam. This cantilever micro beam will be in the order of 100 nanometer thickness, which is used. The surface of the cantilever is used as a biosensor. Next slide. And this cantilever can to detect the static bending or the stress formation of the formation that takes place due to the microorganisms. So these are the application of cantilever type biosensor. And this can be useful for chemical and biological sensing applications, for DNA detection, proteins, antibodies, and the growth of microorganisms. These cantilever-based biosensors having a cantilever beam that is shown in the image, and the microorganisms are allowed to grow on the cantilever. On the surface of the cantilever becomes the sensor, and the further transduction principle like piezo electric or resistive or capacitive type of sensing is adapted in order to faithfully convert the force that is generated, and the amount of bending is measured as a concentration of the microorganisms, or the population of microorganisms can be estimated using these cantilever based biosensors. Next slide. Next slide. Few slides are repeated. Next slide. Next slide. Next slide. Uses of biosensors. Yeah, the use of biosensors, apart from the applications in various domain applications, biosensors can be used to construct a complete instrumentation setup. Biosensors is a part of a detection electrochemical process or biological process is converted into a suitable electrical form. Then after it is being converted into an electrical form, it must be connected with a display that will display the like blood glucose values as a point of care devices. And also it is biosensors are useful for development of next level of micro devices, which is also called as wearable devices. So in the future, nowadays, in recent technology, smartwatches are very popular, which is able to find the heart rate of human being, respiration rate. So the devices can be developed using the biosensor or lipid proper variations in the oxygen saturation. And during this pandemic situation, various vital parameters are varying for the normal patient or the patient that is affected with a particular type of diseases, where it symptoms to various parameters like respiratory parameters, heart rate parameters, and also oxygen saturation. Therefore, these biosensors are, further useful for development of wearable devices. Nowadays, wearable watch type devices are very popular. Even the normal people, they wish to use a smartwatch instead of a ordinary watch. Therefore, the practice of using wearable devices is already in practice, which helps the development of new technologies like integrating the biosensors inside the wearable smartwatch. So these biosensors paves the way for development of these wearable biosensors in the near future. And the other one is implantable biosensor. Implantable biosensors are like few implantable medical devices are available in the market, like the pacemaker. And the further improvement of these implantable biosensors are like intracranial pressure measurement that we'll see in the later slides. These are very important for in the medical diagnostic techniques. And for the development of lab on chip, these are the uses of biosensors. Biosensors not limited to one particular, that is sensing area. It can also be integrated for the development of a complete instrumentation, or the future towards the future need. It can able to integrate to wearables or implantable devices. Next one. Okay. And next one. Next. Oh, next. Few slides again. Go. Next. This management of diabetes. These are the examples of biosensors that is commercially available. Like glucose biosensors are available in the market. 90% of the world market of biosensors are occupied by blood
biosensor.
And biosensors are useful for respiratory monitoring setup, which is helpful for monitoring infectious diseases and spread of diseases. Next slide. And other biosensors are useful for the research purposes. Most of their biosensors are used in research purpose, whereas some are commercially available. But the major applications are in the commercial applications. Next slide. A biochip, a biosensor can be integrated to with microelectronics to produce a biochip, which is a combination of biochip and microelectronic circuitry. It also incorporates a wireless device for further sending this data to the remote server, which is helpful for physiological health monitoring of patient, or it can be environmental monitoring from a remote environment. In agriculture, various types of biosensors are used in recent trends. Precision agriculture is becoming popular. Aqua farming is popular. Sustainable agriculture techniques and water management techniques are useful for agricultural application. Therefore, these biosensors can be able to detect the quantity of pesticide, quality of air, humidity conditions, and quality of soil are determined using this biosensor for industrial applications. Go to slide wireless biosensors. Yeah, this is a biosensor that is it is useful for the determination of concentration of the analyte, and it can integrate with it is having a scope of integrating with microelectronic circuitry like microprocessor and a wireless device. Therefore, it can able to be useful for determining the patient vital parameters like ECG wirelessly transmitted, body temperature wirelessly transmitted, oxygen saturation, insulin level, the diabetic level, and insulin pump values and blood pressure values. These biosensors are combined to a single node of display and can be communicated to the remote server for wireless sensor monitoring. As a conclusion of biosensor, various techniques has been employed, various sensing techniques have been employed for transducing the biological reactions into the electrical signal, and there is a scope for converting this biological sensing output into a wireless technology or wearable technologies. Go to design of biosensors. Design of biosensors. Design of biosensors. Let me make it brief. Design of biosensors. Please go to design of biosensors. Design.
So the
Design of biosensors, like it involves design of biosensors involves design of electrodes for detecting the electrochemical reaction. So the biosensor electrode can be developed by using surface coating methods or electroplating methods. Nowadays, 3D printing has been employed, has come recently for the manufacturing of electrodes. So that will advance the development of biosensors, and it also accelerate the new development of bio into a possible sensing characteristics. Next. Yeah, this is a microfluidic circuit. This is mainly useful for the detection of cancer cells, and this is fabricated using the microfabrication method. Next slide. You can go to cantilever design. It's an intracranial pressure sensor. Previous slide. So cantilever based sensors. Next slide. Cantilever based sensors plays a vital role in determining the biological component sensing, especially the microorganism growth. And this cantilever based sensor design has been elaborately explained, and which uses the surface micromachining technology. In surface micromachining technology, the substrate is made of silicon. A coating of silicon oxide layer is made, and over that a coating of sacrificial layer, that is a piece phosphosilicate glass is made, and this sacrificial layer can be suitably etched out and using the pattern transfer techniques. And the final cantilever, that is a structural layer, is again coated on the cantilever on the sacrificial layer by suitable patterning methods, and the removal of a sacrificial layer that creates the microstructure to be developed, and that is useful for application of development of cantilever based biosensors. Next slide. Next slide. Design of stop. Yeah. Now the design of cantilever beams is very important, and design of cantilever beams involves finding the parameters of the dimension of the cantilever beam in terms of length, width of the cantilever beam, and the thickness of the cantilever beam. There are also design restrictions to be followed in microfabrication techniques, like the thickness of the beam is limited to 2 micrometer, and the distance between the substrate and the is also restricted to be 2 micrometer. So applying various countries suitable design, the suitable design can be achieved. Next slide. Next slide. Next slide. Yeah. The cantilever beam design, to achieve the effective cantilever beam design, it has to go through various analysis steps. Like it has to go through force analysis, it has to go to stress analysis by developing a three-dimensional model. The slide what is shown is a cantilever beam that is developed. Cantilever beam that is developed and is designed using CAD software. This can be developed. The CAD software can be integrated with the suitable specialized softwares for the development, for the analysis purpose. But analysis purpose, we needs finite element methods for the analysis technique. Like static modeling is also used to identify certain parameter or optimize certain parameter. Three-dimensional modeling is also used for optimizing certain other parameters. Next slide. So in order to find the optimum dimensions of the cantilever, various analysis techniques have been performed. Next slide. This is the what is it, meshing process. Before going for the analysis, in three-dimensional geometry, it has to be employed with the meshing process. Meshing, various types of meshes are shown here. Usually, three-dimensional meshes are used for analysis. The tetrahedral is used. Manhattan bricks is one of the popular type of meshing that is used. Pyramid-shaped and prism-shape of meshing is also used for meshing process. After meshing process only, it is subjected for analysis. Next slide. The basic analysis is the mechanical type of analysis, which employs, next slide, which applies the force on the cantilever. Usually cantilever is like having two ends, say fixed end and the free end. The free end is subjected to bending or displacement. The fixed end does not have any bending or movement. And the force applied is on the tip of the cantilever. In the three-dimensional simulation, it is clearly shown that the tip of is shown as a red in color, which is exhibiting the maximum force. But the maximum stress will not be applied on the at the same end, because the forces are distributed throughout the beam. Next slide. So that can be clearly shown in the stress analysis. Okay. The stress analysis clearly shows that the where the fixed end is there, the stresses are maximum, and this paves the way for identification of location of the sensor. The sensor component like capacitive sensor, principal, or piezoelectric or piezoresistive has to be properly placed at the particular location where the stresses are high. That analysis can be performed for the design of cantilever beam. Next slide. Next slide. And this is called a frequency domain analysis. These analysis also has to be performed before arriving a effective, efficient geometry of the microstructure. And this is the frequency domain technique. Like the cantilever beam is subjected to frequency of 1 hertz to 1 megahertz. And at every frequency, the structural variation takes place. For example, these are considered as the modes. It is shown as 8 type of modes are available are shown in this image with the 8 frequency of oscillation. And in each output, it is shown that in the first one, the frequency is around 9.8 hertz, which is having a flat structure. When the frequency increases to 60 hertz, there will be one peak that is towards a downward. When the frequency is increased to 79 hertz, again the same geometry of flatness comes. And when it is increased to 173 hertz and 256 hertz, the geometry varies. There are two peaks are observed, and in 256 hertz there is a twisting of beam occurs. Therefore, at various frequencies, the geometrical shape varies. This causes a failure of the. This causes increased stress on the fixed end that will lead to the catastrophic failure of the device. Therefore, we need to identify exactly what frequency is suitable and for a normalized movement to take place. From this analysis, we can say the first frequency and the third frequency are suitable. That means this particular design can be useful for frequencies from 10 hertz to 79 hertz. From using this modal analysis, this information can be inferred. Using this modal analysis, the frequency is determined. This frequency is useful for the determination of other parameters like stiffness and mass element. And in stiffness is connected with the Young's modulus. The Young's modulus of the silicon is constant, so we can have that parameter. And mass is determined by the volume into density. Volume is determined by length, width, and the thickness, which has other three parameters. So optimization, determination of one parameter will helpful for the optimization of the other dimensional parameters. So these are the various analysis performed, like mechanical analysis, stress analysis, and modal analysis has to be performed before reaching the suitable geometrical shape. Next slide. So these analyses are performed in the specialized softwares, like ANSYS is the basic software that is useful for this one. Next slide. Next slide. Yeah, this is the optimum design has been achieved because the stresses are concentrated not at the extreme end, it is concentrated at the middle end. So a suitable dimension has to be achieved by doing all these processes in an iterative manner. We can't come to a conclusion like this is the particular geometry can be preferred by simple experiment. It has to go iterative steps to come to a optimized shape. Next slide. There are also MATLAB can be used for finding the frequency domain analysis, and that is also helpful for to certain extent for in the design process. And in this image, it is shown that multiple peaks are there. Therefore, these modes are rejected. Only two peak, one line is straight. That mode can be chosen. One line is going, that is to one peak and going down. So from 0 to that maximum peak that is shown in red in color, that can be suitable for MEMS, that is a biochemical reaction with high sensitivity. Other modes of operation and this dimension can be ignored. Next slide. And a comparative study between MATLAB simulation and three-dimensional simulation is also required. It shows that MATLAB simulation gives only a line which is difficult to infer, and a three-dimensional shape will give more information in terms of the user can identify the peaks of how many number of peaks that is coming. So these parallel types of analysis has to be performed before coming to the optimized shape or geometry. Next slide. Next slide. From this optimized analysis conditions, optimized parameters can be determined. Optimized parameters can be useful for in getting increased sensitivity and maximum deflection. The parameters we can able to determine is length, width, and thickness of the micro beam, and the stress and the sensor location can be determined based on this optimized optimization analysis. Next slide. Various design tools used. Next slide. Various design tools used for this biosensor design is actually MATLAB tools can be used for lumped parameter modeling, which is having many limitations. It can also be used for frequency domain analysis to certain next slide. To certain extent, ANSYS is a suitable software for designing the microstructure and also performing the analysis. And the modeling can be done using CAD software, or Autodesk can be, the drawings can be suitably made. Nowadays, suitable advanced softwares, especially for the design of biosensors, are available like COMSOL, Coventrware, and IntelliSuite, which can be employed for the development of biosensors and optimization of the parameters. And with these optimized parameters, we can able to get maximum output, maximum sensitivity. And also this simulation, next slide. Simulation are helpful for reducing the time of analysis, time of determining the optimizing shape. So therefore, three-dimensional analysis are to be performed, which reduces our time, and softwares are user-friendly in order to design the biosensors. Next slide. So there is a, next slide. There is a scope for entrepreneurship in the biosensors, because the field of biosensors are interdisciplinary. It is integration of nano system, integration of chemistry, physics, biotechnologist, and instrumentation, optics, microelectronics, integration of everything that is comes under the biosensors, design and development of biosensors. There are many biosensors are developed and it is in use. That can be integrated with the microelectronics and wireless technology for many future applications. And there is a scope for identifying various physiological parameters, environmental parameters, and health parameters to be converted into a design of biosensor. That as a conclusion, biosensors can be very much helpful for solving human problems. Thank you very much. With this, I conclude.
So thank you, sir.
Thank you.
One question from Mureshwari ma'am. She's
Yes,
asking about software available for MEMS-based biosensor and microelectronic circuitry.
Yes, there is a software called COMSOL. COMSOL is having a very flexible and user-friendly software, which is suitable for designing the biological property and integrate into microelectronic circuit. And there is a Coventrware software that is also having a separate module like VLSI. Module is also can be integrated. Therefore, when we design the biosensor in the simulation platform, there is a coupled solver. There is a tool called coupled solver where the mechanical characteristic can be tested and the electrical characteristics can be tested separately. Coupled solver is like we can test the application of force and the output electrical energy, how much it is generated, or the application of force, how much piezoelectric property is varying. So that is called coupled solver, is available in Coventrware and COMSOL software. So specialized software helps the user to design the complete instrumentation setup. Like biosensor part can also be developed. Then the further microelectronic part can also be simulated in the simulation platform. Yes, ma'am.
Okay, sir. Okay, sir. Any other queries from the participants? Okay. Okay, sir. Thank you, sir.
Thank you very much, ma'am.
Priyanka, ma'am.
Thank you. Oh, ma'am. Thank you, sir. It gives me an immense pleasure to deliver the vote of thanks on behalf of the Department of Biomedical Engineering, PSNA College of Engineering and Technology. I would like to thank our guest speaker, Dr. J. Samson Isaac, Assistant Professor in the Department of Biomedical Engineering, Karunya Institute of Technology and Science, Coimbatore, who honor this function with his valuable thoughts on the topic biosensor design and biomedical application. I am sure that participants would be highly benefited. Thank you very much for sharing your valuable information with us. Thank you, sir.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir.
Thank you, participants. We'll meet you again in the tomorrow's session at 9:30 a.m. So sorry for the interruptions due to network disconnectivity. There was a problem. Sorry for the interruption. Thank you. And their participants, feedback link is posted near chat box. Within half an hour, I can finish it and submit your feedbacks. Okay. Meet you again in the next session. Thank you.